In this video, we are learning about the Pythagoras Theorem. And this theorem is just concerning special triangles called right-angle triangles. That is, triangles that have one of its interior angles equal to 90 degrees. That is, this corner is always shown by this side, this corner. Okay. So, and then before we go further, it's important for us to recognize the parts of a right-angle triangle. This part opposite the 90 degrees, this part is called the hypotenuse, and that is the longest side of every right-angled triangle. This part opposite the 90-degree angle. This side. Okay. So, this side is always equal to, the square of this side is equal to this other side squared plus this other side squared. And these two other sides, they have names depending on the angle we consider. For example, if we have this angle, if we consider this angle, then this is already the hypotenuse. The hypotenuse of a right angle triangle does not change. Then this side opposite this angle we are considering is called the opposite. And then this side that subtends this angle, that's the side sharing the angle with the hypotenuse, is called the adjacent. Let's say we are now considering this other angle. If we consider this other angle, then this is always the hypotenuse, the side opposite the right angle, that is the angle 90 degrees. Then this side opposite the angle we consider is the opposite, and then this side is the adjacent. So we can see that the names of these other sides, remaining sides, changes depending on the angle we consider. Now, never forget that the side opposite the angle 90 degrees is the hypotenuse. And the Pythagoras theorem will say, let's say we call this side, let's say this is triangle A, B, C. So this side is small letter B, this side is small letter A, and this side is small letter C. So we can see that this side, small letter B, is the hypotenuse. So it means that B squared is equal to A squared plus C squared. Just these two sides squared. That is what Pythagoras theorem is all about. Now let's look at some examples that will help us to see various scenarios or problem-solving cases whereby we apply Pythagoras theorem. We are faced with this example. We've been asked to find the missing side named x. So what do we do exactly? We recognize that this is the hypotenuse. So remember that from Pythagoras theorem that the hypotenuse squared, which is 10 squared, is equal to this other side squared, which is 6 squared, plus this other side squared, which is x squared. Okay. So we are going to make x the subject of this formula. That is by taking 6 squared over to this other side. So we have that 10 squared, 6 squares come here to become minus 6 squared is equal to x squared. Now we are going to take the square roots of both sides. We now have that x is equal to the square root of 10 squared, that is 100, minus 6 squared, which is 36. We have that x is equal to the square root of 100 minus 36, that is 64. And then we have that x is equal to 8 cm. So we see that. Now let's look at another example. In this particular example, we have a triangle that is a combination of, that is divided into two, so forming two triangles within it. Okay, so seeing that this is angle 90, that means this is the hypotenuse for this triangle, and this is also the hypotenuse for this other triangle. Now, we've been asked to find the sides x and y. To find it, very easy. So what do? We are going to say, we are going to start from x. So x is the hypotenuse. So x squared is equal to this other side squared, 12 squared, plus the other side squared, which is 5. Because just for this part, this is just the length of 5. So 12 squared plus 5 squared. Okay. We have that 12 squared is 144 plus 5 squared, which is 25, is equal to 144 plus 25, that is 169. Remember, this is equal to x squared. We now get the square roots of both sides. We have that x is equal to 13 cm. We see that, right? So in that same manner, you are going to solve for y. Same thing, y is also the hypotenuse of the bigger triangle. Now, we have that y squared is equal to this other side, 12 squared plus. Now, for this part y, the whole length is the length of the other remaining side, which is 4 plus 5, which is 9 squared. We now have that 12 squared is 144 plus 9 squared, which is 81. And then we have that 144 plus 89, that is 225. So remember, this is y squared. We are going to get the square root of both sides. When we get the square root of both sides, we have that y is equal to 15 cm. So we could see the application of Pythagoras theorem. Now let's see one more example. You could go ahead, pause the video, and then try to solve this to see what you could get. Okay, fine. For this particular one, we can see this side is the hypotenuse for this smaller triangle, and this side is also the hypotenuse of the smaller triangle. Why? Because they're the sides facing the angle 90, when we consider that this is actually two triangles we are looking at. Now let's start from the inner triangle. Now for here, we have that the hypotenuse squared. So the hypotenuse is 10. 10 squared is equal to this other side squared, 8 squared, plus the remaining side squared, in this case x squared. We now have that 10 squared is 100, equal to 8 squared is 64, plus x squared. Now we are going to get this out of the way. 64 going over to the other side. We have that 100 minus 64 is equal to x squared. 100 minus 64 is 36. We get the square root of both sides. We have that x is equal to 6 cm. Now, same thing for this other part. Now we have that the hypotenuse for this whole triangle is 17. So 17 squared is equal to, now for this whole triangle, this is still the other side, which is 8 squared plus. Now for this part, it includes x plus y. And then for x plus y, we've already found that x is 6, then y, we don't know what y is. So we could call it a particular letter, or we just say x plus y squared, or just, since we found x, let's have it as 6 plus y squared. 6 plus y squared, all in a bracket here. Now, we are going to have that 17 squared. So we take this over to this other side. We have that 17 squared minus 8 squared is equal to 6 plus y, all in a bracket, squared. We are going to get the square root of both sides. So let me take this over to this place. So 6 plus y, all in a bracket, squared, is equal to 17 squared minus 8 squared. Remember, we are taking the square root of both sides. We have that this is 6 plus y is equal to 17 squared minus 8 squared, and then the square root of that is 15. We have that 6 plus y is equal to 15. Therefore, 6 is equal to 15 minus. Therefore, y is equal to 15 minus 6, which is equal to 9. Now, let's have a little bit different question. The diagonals of a rhombus measure 8 cm and 6 cm. What is the length of the side of the rhombus? Now, remember that a rhombus is a four-sided figure, that is a quadrilateral that has all the four sides equal. So I'm going to try as much as possible to make the sides equal. Then the opposite angles are, like these opposite angles are equal to each other, while these other ones are equal to each other. Now we have that the diagonals, that is from this edge to this edge. So let's say that this is 8 cm, broken lines, this is 8 cm, and for this one is 6 cm. Now, one of the properties of a rhombus is that the diagonals bisect each other. That is, as they cross each other, they divide each other into equal parts. So let's say this was 8 cm. That means this part is 4 cm and this part is 4 cm. If this was 6 cm, that means this is 3 cm and this part is 3 cm. Now, remember, a rhombus has all the four sides equal to each other. Now, we can now pick out this part of this forms a right angle triangle, because the diagonals of a rhombus cross each other at right angles. Now we are going to pick out this triangle here. We are going to have it as, so this is 4, this is 3 cm, and then remember that this is what we are looking for. Let's even name this side X, for example. And then, good. So you can see it's already easy to solve. We see that x squared is equal to 3 squared plus 4 squared, which is equal to 9 plus 25. We have that x squared is equal to 36. We take the square root of both sides. What was I even saying? 9 plus 16. God. 9 plus 16. So we have that 9 plus 16 is 25, the square root of 25, and then we have 5 cm. So the length of the sides of the rhombus is 5 cm each. Now we've used Pythagoras theorem that was originally made for triangles to solve a quadrilateral, the rhombus. Now we are going to use it to solve a problem inside a circle, so it is just wide. Okay, we have that this O is the center of the circle, HKL, and then the line HK is 16 cm. We can see that, and then HL is 10 cm. And the perpendicular from O to HK, so there is a perpendicular from O to HK is 4 cm. So if here is 4 cm, what is the length of the perpendicular from O to HL? So now, if the perpendicular from O to HK is 4 cm, we've now been asked what is now the perpendicular from O to HL. So this is what we are looking for. Now, for this circle, let's use, so remember that this is O. I'm going to use another color of pencil to make sure that we can differentiate the things we have in the diagram and what we don't have. Now, remember that any line from the center of the circle to the circumference is the radius of that circle. So this line that will pass through here is the radius of the circle. So why are we having this? Now, another thing that is important to know is that any line that is perpendicular to a chord, we have the chord of a circle, which is just a line passing from one part of the circumference to another. Any line that is perpendicular to that chord cuts the chord into two equal halves, into two equal parts. That is one of the properties of a circle, chord, and all those things. So that is why I place this perpendicular line here. Same thing with this part that we need. So I'm going to draw that out. We can already see that we have a circle here. You can see we have triangle here, and it's a right angled triangle. So when we have the triangle here, we will look for the radius r. Here we have that this line that is perpendicular to this chord HK, 4 cm. So meaning it's divided this chord into two equal parts, meaning that here is 8 cm and here is 8 cm. Therefore, in this part, when we draw it out, we are going to have this triangle. Let me draw it exactly the way it is here. So this is angle 90, this is r we are to look for, this is 8, and then this is 4. Now, why are we looking for r? When we find r, we now focus on this part of the triangle. And remember that r is their hypotenuse because it is the part facing the angle 90. So when we now have this radius, which is the hypotenuse of this other triangle, we can now find this other part of the triangle, because for this line, it's already divided here into 5 and 5. That's the property of the circle. So let's find the radius from here. The radius is the hypotenuse. So we have that r squared is equal to 8 squared plus 4 squared. And then we get the square root of both sides to have that 8 squared plus 4 squared. The square root of that is equal to 6.928. Now I'm going to leave this as more than one decimal place since it's not the final answer, so that our final answer is not truncated. Okay, we found the radius. Now let me draw that other part of the triangle. So this is the hypotenuse, this is this part, and then so this is 6.928, this is 5, then this is now the length of the chord, the length of the line that is perpendicular to the chord HL. Okay, so we have, so since it's not the hypotenuse squared, 6.928 squared is equal to 5 squared plus x squared, this other part. Now we have that x is equal to 6.928 squared minus 5 squared, all square roots. And now when we do that, we can now have that x is equal to 4.8 cm. 4.8 cm. So we can see that the Pythagoras theorem can be applied to any other shape apart from triangles. So far we can get a right angled triangle out of that shape. And you could as well go over the video once again in case there is any point you don't really understand. Don't fail to ask me your questions.